Hey team, it's Mr. Z, and today we're going to look at another factoring technique. Let's go ahead and try to factor by grouping. Alright, in the last video we kind of learned by chunking, which is very similar, where you kind of look at the first term and see if it's a perfect square. Here, not so much. However, upon closer investigation, normally this isn't something you've trained your eyes to do yet. I want you to look at them as two different expressions. Looking at them as two different expressions, you can see that the green has a GCF. I'm going to ask myself, well, there's two x squares in it. X squared times what is x to the third, and x squared times what is negative 2x squared. Well, x times x squared is x to the third, and negative 2. So this is how I factor this first expression. I get x squared times x minus 2. Let's go ahead and do the right expression. I look at it and I see a common number of 3, right? Well, 3 times what is 3x? 3 times what is negative 6? I get x and negative 2. Now, this is completely lucky that they're the same. This technique, grouping method, is hoping to be able to get it so that I find a common factor between two terms. Now, before I go any further, I want to talk about just general numbers. If I have 3 times 2 and I'm adding 4 times 2, let this 2, I'm going to actually put it in purple just so it matches. So, figuring it out, you could just multiply and you would get 6 plus 8, and then that would give you a sum of 14, right? 14. Now I'm going to show you an alternative way. Instead, I see that there's a factor of 2, and I'm going to pull it out and then leave the inside left over. And if I evaluate that, it's still 14. What I essentially did was I factored out the common 2, leaving the rest. So what I'm going to do here is factor out an x minus 2, and it's going to leave me with x squared plus 3. I cannot factor this any further because this plus sign gets in my way. So I'm going to end here, but I just want you to understand that I was able to factor this by looking at the two parts and trying to find a common factor between them all. So let's go ahead and continue. This next guy, x to the fourth minus 3x to the third minus x squared plus 3x. So there's a couple of ways of doing this. You might initially see one thing or another, but I immediately see that they all have a factor of x, right? So I'm going to factor out x, and I'm going to ask myself, x times what is x to the fourth minus 3x to the third minus x squared and 3x. Remember, this is just to help me figure out what is the factor. This is going to be x to the third. Well, I need a negative 3x, 2 more x's, negative 1 times x plus 3. So I was able to factor out x times this expression is going to give me my original. So voila. I have x to the third minus 3x squared minus 1x plus 3. I don't really know how to factor this right now. It's not a perfect square, but if I'm going to go ahead and look at it, I see this part and this part. So it's going to be x times. Let me go ahead and just zoom in on the inside. I have x minus 3x squared. I hope you can identify that x squared is the GCF times x minus 3. That produces this on the top. Here I have, well, what am I going to pull out? I don't know. There's really nothing in common. But look at this factor. I want it to match. I want to get x minus 3. And currently it's plus 3. So I'm going to actually factor out a negative 1. And this is going to require me to have x minus 3. Let me make that a little more clear. So by factoring out a negative 1, it enabled me to get a positive x and a negative 3, aka allowing me to match. So this is going to produce, remember this x is just kind of there in the front. I'm going to have x minus 3, and then what's left? X squared minus 1. So this is called factoring by grouping. Some of you might think you would be done at this point, and you wouldn't necessarily be wrong, but I do see this guy. So before I go on, I'm going to just kind of clean it up. I'm going to drop that parentheses. It's unneeded. And I'm going to go ahead and factor x squared minus 1. I see a perfect square, and a subtraction sign. All of these are signs that I should factor it. So let's go ahead and factor this last guy. This is going to be x times x minus 3 times x plus 1, x minus 1, and voila, completely factored. Notice degree 4, 1, 2, 3, 4. That's not by accident. If you want to see the area model for how I factored x squared minus 1, it would look like so. X squared minus 1. And then I want you to pay attention to the interaction between this and this. Cancels out, leading me to get just x squared minus 1, meaning it's a factor. Hope this helped, team. That's it for now.